Welcome to Tales at Scale, a podcast that cracks open the world of analytics projects. I'm your host, Rena from Imply, and I'm here to bring you stories from developers doing cool things with Apache Druid, real-time data and analytics, but way beyond your basic BI. We're talking about analytics applications that are taking data and insights to a whole new level. We all know that APIs are fundamental to modern software development. That's where Kong comes in. They provide the foundation that enables any company to become API first. And the numbers don't lie. At the time of this podcast, Kong is seeing over 400 billion API calls a day in a community of over 160,000 and counting. Built on the world's most adopted API gateway, Kong's unified cloud API platform delivers fast, reliable, and secure digital experiences so developers can focus on other/better things like performance at scale. Joining me to talk about what Kong is working on is Hiroshi Fukada, staff software engineer at Kong. Hiroshi, welcome to the show.
Hi, thanks for having me.
Okay, so I like to start every episode with a little bit about my guest background. So tell me how you got to where you are today.
So my first dip into the data world was working for a startup that used to be called Deepfield. They got acquired by Nokia, but they did analytics and information around data monitoring around routers, NetFlow, internet traffic, basically. And we'd use collected data from different people, including CDNs, transit networks, even subscriber networks as well. Using that, we built products that were meant to do outlier detection. So if a router went down, you'd see NetFlow go down. We also did some stuff around DDoS detection. And there's certain characteristics that you can see inside of a data stream that you can try to detect before it happens or before DDoS goes out of control to be able to stop it right in its path. After that, I went to do a little bit of work over at Toyota Research Institute for their autonomous driving division and handled a lot of their data labeling, data cataloging, data searching, all that sort of stuff for their enormous amount of data that they collect on these drives. And there's like 20 cars and they all have like 50 billion sensors on them. So categorizing and being able to search all that data is quite a problem as well.
So you're like a data guy, like through and through.
I started data probably like, I don't know, 7, 8 years ago, something like that. So I have been around for a while now, I guess, and I've seen some crazy stuff.
So at Kong, what team or department are you part of?
I am part of the data team at Kong, and we're mainly in charge of getting customer data up through the gateway and into our platform, Connect, which customers can use to view and analyze the data that we collect.
Oh, awesome. And so can you, in your own words, kind of tell me a little bit more about like what Kong does?
Yeah, Kong, well, let's separate the two different things. I'll talk about Kong first and then what Connect is. So Kong is the plumbing for all your APIs. You can have different APIs being served on different clusters, different servers, even different upstreams that aren't even yours. Kong allows all your services to talk to each other in a unified sort of way. All the authentication, all the authorization is handled through these pipes. It makes it super secure and it's super, super fast. We're the fastest API gateway out there today. And we are constantly trying to improve our features and our performance. Separately.
Oh, I was going to say, tell me about Kong Connect.
Yeah, separately, Kong Connect is kind of the one-stop shop to manage all your plumbing. As companies evolve and have more and more APIs that they want to support, they have different needs. They're not just about connecting services together. It's also about enabling others to find your services. So Connect also allows you to have a catalog of all the things that your services are doing. And Connect allows different developers or customers to come in and search what you have. Nobody wants to write the same service twice. If somebody wrote a currency converter, you're going to reuse that. And Kong Connect allows people to search for those services that exist. And of course, stuff like authentication and authorization are handled all between all of that as well. And Connect helps you manage that. On top of that, we have analytics that comes in. And this is my team's Mojo. It's basically running everyone's Grafana and Datadog all at once. And so people should be able to come into Connect. If something's going on, they should be able to come into the platform, search what's going on. We have API request logging. We have analytics. You can get per service, per consumer, any graph that a customer may want to be able to tell a story about what's going on in their network, who's doing what, and what's happening. So that's kind of where we're at today for the data analytics and Connect. We're looking to also it also provides a nice federated management across all your APIs as well. So from high on high, you may have decrees that certain services be protected in certain ways. And so Connect allows you to come in and say that I will demand that if you're going to publish an API, that you should have these types of security features set and these types of criteria need to be met. And so Connect as a platform provides a federated way to manage all your APIs.
And I believe, correct me if I'm wrong, the analytics portion of Connect is where Druid is, right?
Yes, that is exactly right.
Okay, perfect. So were you familiar with Apache Druid before working at Kong? Had you used it before?
Yeah, I had played with it a little bit because back in Toyota Research Institute, we had a ton of driving logs to catalog, and they were all kind of muddled around different places. And I had toyed with the idea of storing all these old car logs inside of Druid, which would be super nice if we could use it for searching for certain like high acceleration, deceleration events, looking for certain objects that do and don't exist, model confidence, that sort of thing. I didn't get to finish that project, but I did get to see how powerful Druid was, and it certainly piqued my interest because it was doing a lot of smart things. And as someone who did a lot of dumb things in the previous job, Druid seemed to solve a lot of those issues for me.
So, going back to Connect and the analytics portion, were you a part of the process, like searching for a new database, or was there another database before Druid that was being implemented there?
So previously Kong used to be a on-premises product, in which case everybody used to run their own Postgres instances. Everybody ran or something else. We support many databases, but all the analytics would also just flow to the same database, which doesn't quite work. And so when we started firing up Connect, it was immediately apparent that we shouldn't be running a million instances of Postgres. So we were looking for something else to handle all that. And we weren't really interested in running a Prometheus for everyone either. And so the two front runners I remember when we were deciding where we should go was Apache Druid and Pinot. I had come with a little bit of experience with Druid, and I felt like we could get off the ground fairly quickly. So we went with Druid.
Awesome. Okay, since you know Druid, what were some of the features that you needed for this that Druid was good for?
So we knew that we needed to be low latency from event to be able to display inquiry. So Druid's real-time data processing, natively supported Kinesis and Kafka were all super important to me. The SQL and native query languages are things that everybody can pick up. I know SQL is super useful and super universal, but it's not super programmer friendly to a degree. And so we actually use the native query language almost everywhere when we write our code. So it's very nice. We were able to get up and running fairly quickly, and it was super easy to tune to what we needed it to be.
Not to go off on a tangent, but why do you feel like SQL is not always super friendly?
Because managing writing code to write another piece of code is always just difficult if you're going to try to cover all the generic cases. That's why there's so many ORMs and different query layers, that different libraries and stuff that exist to do that for you, because it's hard. It's legitimately hard. And so we didn't want to commit to using an ORM or a query writer because we didn't really know where we were going. So we just used the JSON query language that is provided, and it's honestly pretty powerful and it gets you a long way. So we are thankful for that.
Can you walk me through where Druid sits in your data architecture and kind of what your data stack looks like?
Yeah, I'll start at the origin. So Kong Gateway sits on our customers' networks. A request happens, it proxies it. proxies it. It creates a data point with different attributes, and then it gets sent up to our ingest, which is k ingest, which we call king. King sips it up and then immediately puts it on a Kafka topic, and then a Flink job reads that message, enhances it further, like enforcing tenant ID and other enhancements that we want to put on. And then it puts it back on another topic, in which case Druid picks it up and ingests it for us in a few different shapes. From there, we query those different shapes in our API and then expose that through our Explorer API, which is visible inside of Connect today.
Did you say it was called King, so it's King Kong?
Yeah, it's basically King Kong.
That's amazing. I don't know if you have this like off the top of your head, but can you tell me like ballpark, like how much data you're ingesting on a daily basis? And with that, like what are you seeing in terms of query speeds?
So I think we're on the order of 5 million something, 6 million events a day, multiplied out because we ingest in two or three different shapes. So on the order of like 15, 20 million unique events ingested and queryable. The latencies that we see from event to being able to be displayed in the UI highly depend on people's networks, but on the low end, it's a couple seconds. On the upper end, you might hit, depending on people's upload frequency, it could be like a minute. But we try to keep that default number fairly low so that people can see their data basically immediately within 10 seconds. I would say the median's probably around 10 seconds for the first interaction, because we try to be really optimal about when to send up.
So you chose the path of using Druid with Imply. Why go with like a vendor versus open source, since you know kind of both?
Yeah, actually we got off the ground using the Druid Helm chart. Actually helped maintain it for a bit.
We'll get to that. We'll get to your contributions.
That was kind of our proof that we could make it work for us. And then we said, let's go to production with it. Let's not use a Helm chart. We'll use Imply. And one of the big reasons is because managing infrastructure is a lot of work. A lot of people don't give it the credit it deserves. There's a reason why SRE teams exist in every single company, and we didn't want to become an SRE team. A lot of the things that are complex about Druid are like, oh, what version are you guys running? I was like, what JC2 instances? Like, can you have zero downtime upgrade events with what you are running with? So, like, the answer is probably, but it would take a lot of time, potentially a whole person's full-time time. And we didn't want to get into that. We just wanted to get into building the product that we wanted to build. So Imply was right there. And so we came out to talk to you, and here we are.
Awesome. I mean, yeah. So you get to do like the fun stuff instead of just spending all your time like doing the management and maintenance portion.
Yeah, I mean, there's certainly lots of knobs to turn, even with what we have today, and we're trying to be as run as slim as possible. We're trying to be real budget friendly, and data is one of the most expensive things that we do. Like, it's not creating an entity, which is a row in a database, which is fractions and fractions of a cent. This is actual. When you're running on customer-sized data and they're doing millions of requests a second, and you're handling n of those, then it becomes a big problem.
Are there any other, additional use cases or integrations you're exploring?
Yeah, we're looking forward to some more options for compaction in the future and being able to query from deep storage. One of the limiting factors for Druid and what we can provide for the speed that we do is you keep a lot of data hot so that it's immediately available, but we could provide a different experience that is querying from deep storage so that we don't have to delete the data off the hot set and never see it again. This is one of the things that we're most looking forward to in the native query engine, because it doesn't exist right now. It's only for SQL, but we are excited for the native way to query history. And then the other thing is the compaction. Compaction has been a mystery for us for a while because we used a larger data ingest format than we do today. And so compaction tuning was a bit of a mystery to us. And we would also like to do like step by compaction. So you might ingest at 10-second granularity, and then a day later you roll it up to 60 seconds, and then 30 days later you roll it up to an hour, but all on the same data source to make it really, really easy. That would be cool.
Yeah, that would be. You know what? The part of this show is like seeing what's on people's wish lists and like being connected to the community and keeping track of like what is on the roadmap for subsequent Druid releases. So I feel like I'm going to take a look and see what's going on. All right, let's shift gears back into open source Druid because that's how you and I actually originally connected over a community extension committed by Kong and Druid29, which was DD Sketch, which I thought was Datadog, but it was actually Kong. And you were kind enough to walk me through it for an article I did that I'm not going to rehash here because you can go read it and I will link to it. So thank you again for talking me through it. But for the folks who haven't seen the article or haven't heard of DD Sketch, can you tell me what it is and who should use it and how they would benefit from it?
Yeah, DD Sketch is a sketch-based algorithm, which means that you're getting approximate quantiles out of this thing. It is a value error guarantee type of sketch versus a rank error type of sketch, which is provided natively by Druid itself, and it's exposed on the double quantile sketch, that sort of library. The difference between value error and rank error guarantees is that rank error gives you a guarantee that if you ask for something like a P99 or let's go with P90,
mm-hmm.
and you go with P90 and you get a rank error of 1%, then you're guaranteed to get an answer between P89 and P91. For stuff like network latencies, which we deal with, the most hard question for these types of queries is a distribution that is long-tailed. So your P50 or your median could exist at 20, 30 milliseconds. But the long tail of P99 and anything above P90 really can go up to like 15 seconds. Let's say that your P95 is 10 seconds. You're guaranteed an answer somewhere between probably like 5 seconds and 15 seconds. And the other thing that was kind of unnatural about the double quantile sketch that Druid provides is that it's kind of a random based algorithm. So you could run the query twice and get two different answers out. When you draw this on a line and you have something like auto refresh enabled, you get lines that wiggle, and people get confused about that. The nice thing about DD Sketch is that it's a value error guarantee. And so what this means is that in our previous example, if you have a P95 that is something like 10 seconds and you have a value guarantee of 1%, then you get a guaranteed answer of 10 point something that exists between 9.9 and 10.1, which is way more the characteristic that people are looking for in something like a long tail distribution. The other thing that's nice about it is it's tunable. You can change your error rank guarantee, and you can also it also doesn't do random distributions. So you ask it the same question with the same distribution, and it will give you the same answer back. So you no longer have wiggling lines.
No wiggling lines. I got it. Okay, so I actually want to end this episode with like a little bit of a fun thing. So I'll let you choose your own adventure here. Do you want a music-based question or a video game-based question?
Video game.
All right, what's your go-to video game? What's your favorite?
I have played Dota 2 since 2013, and I continue to play to this day. I hope to be able to play this game for several more years because it's kind of like my social outlet to talk to my friends that exist in different parts of the country.
Oh my gosh, that's like the same with my former roommate. Like that's how he and his best friend hang out because they live in different states. But it's usually like Dark Souls or Overwatch.
Yeah, I need that competitive edge. I need to make the kids cry.
Oh my gosh, that is like the perfect way to end this episode. So thank you so much. Thank you, Hiroshi, for coming to do the show. And, if you want to learn more about what Kong is doing, please visit konghq.com and make sure to check out the blog that we have put together on imply.io. And if you want more information about open source Druid, please visit druid.apache.org. Until next time, keep it real.